Hey, good morning, guys. So, wanted to set you guys up for understanding what you're looking for when you walk through this lab simulation. All right, so the title of the lab, you can find it's called What's in That Bottle, and it's pretty straightforward in what it says. What we're trying to do is figure out what type of bond is holding together a series of unknown substances. And you're going to find out that there are 6 unknowns that you're going to have to identify, not who they are, but simply what type of bond connects them. And if we're going to do that successfully, we have to be able to run a battery of tests on our solids, sort of like if you go to the doctor. And some of those tests don't confirm what something is, but eliminate another option and help narrow the field. Some of those tests are more confirmational, where we think we have it narrowed down, and now we're going to try to confirm it with that test. And just like always, you want support. You don't want just one test that says, oh, it's this, right? We want a series of tests that all kind of work in unison together to confirm things. All right, so the 4 types of bonds that we focus on, are ionic bonds, metallic bonds, and covalent bonds, which you guys know come in 2 types. Polar covalent, where there's a dipole moment and the electrons are shared unevenly, creating partial negatives and partial positives. And the nonpolar covalent, where the electronegativities are relatively the same, so you get an even distribution of charge, and you get a London dispersion force that comes and goes because there's nothing that keeps the electrons held in a place to hold a dipole moment for any sustainable time. So the first thing we're going to do is take a series of substances that we know what they are and test those. And when we test those, we're going to start to know what results should look like if it's that bond type. And so we're going to take a substance we know to be ionic, copper 2 sulfate, and we're going to run it through a series of tests. And you're now going to know what ionic substances tend to look like when we have those tests conducted on them. Then we're going to go and we're going to test zinc, which we know zinc is a metal. It's a pure metal. It would be a metallic bond. However, the zinc acts, that should be characteristic of how all metallic bonds would act. Similarly, we're going to test a substance called dextrose. Like dextrose is a polar covalent substance. And we're going to test a substance called paraffin, which is a great example of a nonpolar covalent substances. So the question is what is this battery of tests that we're going to conduct? All right, so if we take a look, we're going to run a whole bunch of diagnostics on these bond types. Some of them are testing for physical properties. Some of them are testing for chemical properties. All right, so I'll do the physical ones first and talk about what each one means. All right, then we'll talk about the chemicals, and then I'll run you to the back, and I'm not going to run through the whole experiment, but I'm just going to show you what the setup would look like so you get a feel for how the experimentation portion would be. All right, so first things are physical. Right? We're going to look at the thing. We're going to take a look at its color. We're going to take a look at its texture. Why? All right, well, color and texture will not help you very much with ionics, polar covalence, or nonpolar covalence because an immense amount of those tend to be white solids. Some of your ionics will have color, but most of your ionics, polar covalence and nonpolar covalence, are going to be a white crystal, a white solid. But your metallic substances, they're going to be shiny. They're going to have luster. All right, so that's a unique characteristic to metallics. So it's kind of a quick litmus test of, hey, is that thing a metal or not? All right, and you just do that by observing. All right, then what we'll do is we're going to check for conductivity in the solid form. All right, if I put an electric current through all 4 of those bonds, only one of the bonds will allow electricity to pass through it. And it's the metallic bond because only the metallic bond has those free-flowing electrons in the electron sea that can carry that current across the solid. In the ionic bond, there's no movement of charge. Your opposite charges are locked in place, positive, negative. Covalent bond, the electrons are overlapped in the electron cloud, so they can't move that much. And if you can't move electron, you can't carry charge. So this would be another test that helps us confirm if a substance is metallic. If it conducts as a solid, there's a really high chance it's a metal. If it doesn't, it's probably one of the other three. So we need to be able to narrow it down. We have two good ones that help us identify metals. How do we get these other ones? You dive a bit deeper. If we look at the melting point of a substance, what the melting point tells us is about the strength of the bonds in the intermolecular forces. All right. Ionics, metallics, and polar covalents have high melting points. Non-polar covalents have low melting points. All right, so if we're getting a melting point below 100, there's a decent chance that it's got really weak IFs, and the only three of those that have really weak IFs are going to be your non-polars, right? They just have those London dispersions. Ionics, strong IFs. You have an ionic IF. Metallic, strong IF. It's a metallic bond. Polar covalents, you can have dipole-dipole, you could have hydrogen bond, and you've got London dispersion, which tends to make those a bit stronger. So the melting point might be a good way to isolate a non-polar covalent type bond. Then we get into some solubility stuff, because we know there's this idea that like attracts like and like dissolves like. And what we mean by that is substances that are structurally built like each other can form interactions. And because they can form interactions, we can break them down. All right, so here's a series of solubility tests that will help us narrow the field for the bond type. If a substance is soluble in water, there is a decent chance it is like water, meaning it is polar. Right? And of the ones on our list, the only two that might fit that criteria are a polar covalent, polar with polar. Ionic, we know, is superpolar, and it says sometimes, and I'll talk about why. But your metallics and your nonpolar covalents will not be dissolvable. They will be insoluble. Metallics, because they're too strong of an interaction for the water to overcome. And nonpolar covalent, because there's no constant dipole moment that the water can come up and create a binding force with to break it down. All right, so your nonpolar covalents and metallics won't be soluble. Polar covalents will be soluble. They will dissolve. Ionics will be sometimes. They're polar, so you expect them to dissolve, but every month you got to take a solubility rules quiz that helps us remember certain ionic substances are naturally soluble, certain ones are not. For instance, sulfates, like the one we did, copper 2 sulfate, sulfates are soluble. Copper is not one of your exception. Anything with a group 1 metal, soluble. Anything with ammonia, soluble. But there will be ionic compounds that are insoluble, right? Sulfides, carbonates, chromates. These types of substances, even though they're ionic, they are not soluble. That is why this says sometimes. All right, so first solubility test is with water. Second solubility test is in hexane. Hexane is a non-polar substance. It's a carbon chain, right? Remember, carbon chains that only have H's on them, always non-polar, which means if I dissolve, I must also be non-polar. So my non-polar covalents will be soluble. My ionics, my metallics, my polar covalents, they will be insoluble. Following that train of thought, solubility in ethyl alcohol. Ethyl alcohol is a polar covalent substance. Right? So does it dissolve? If it does, polar covalent, like dissolves like. And a little bit of non-polar covalents might dissolve as well, because at the end of the day, they're still covalent. So it's covalent dissolving covalent. But polar covalent will slightly be soluble. The non-polar, a little less so. But your metallic and your ionic, they will not be soluble for that. Then, if the thing dissolves in water, we want to see, does it conduct electricity? Because that helps us narrow things down. If the thing dissolves in water and it conducts a current, we know it's polar covalent. We know it's ionic. Metals won't dissolve at all. Neither will nonpolar covalents. That's why it says not applicable. And so you're going to see some of those show up in your results where it's like, oh yeah, how do I know if it conducts in water? Well, if I can't get it to dissolve, I can't see if it conducts in water. So these are all physical traits about the bond types that we would be assessing. There are a few chemical ones as well. We're going to react each of these substances with a couple things. The first is hydrochloric acid. If I react the substance with hydrochloric acid, right, I can start to narrow some things down. If that substance is a metal, right, it will create bubbles, and here is why. If I take a metal and I put it with HCl, it's going to trigger a single replacement reaction where the metal comes in and kicks out the hydrogen. So we'll get some type of metal chloride, which has a really good chance of being soluble because group 17s are soluble. And I'm going to get hydrogen gas by itself. So if I get a metallic substance, it is going to create bubbles because it's going to evolve hydrogen gas. What's going to happen if it's not a metal? If it's ionic, it might dissolve, but we won't see the sign of a reaction. An ionic substance is going to dissolve because HCl is polar, just like the ionic is, but you won't see bubbles. You won't see the evolution of a gas. The metals, the nonpolar covalents and the polar covalents, they won't dissolve, all right, in those setups. All right, so those would be non-applicable. What if I react it with NaOH? If it's with NaOH, there's a pretty good chance that the ionic substance might form a precipitate, because if we do a ionic substance, we're talking metal with non-metal, and if we put that with NaOH, as we double replace, you're going to get Na with a non-metal. Because it's group 1, it's going to be soluble, but there's a lot of metals that when I put them with OH, right, they are insoluble because hydroxides are insoluble. So the only time this would break down is if my metallic substance in my ionic bond was a group 1 or one of the tetris pieces from group 2. All right, so we would see a precipitate from this, and that's a sign of chemical reactivity. All right, so if I react it with NaOH, the ionics might make a precipitate, barring those few examples. Your nonpolar covalents, your metallics, they won't initiate a reaction. And your polar covalent, because this is also polar, it'll dissolve, but it won't react. All right, so it'll disappear, but you won't see any sign of a reaction. All right, the last one is what happens if we react it with water. And what we'll do there is we will test the pH in water. And the reason we do that is if the pH changes, that is a sign of a chemical reaction. We've created a new substance that has acid or base characteristics. All right, so if I take a metal plus water, what will happen is the metal will come in, kick out the hydrogen like we talked about, and we can form a metal hydroxide plus hydrogen, which is one of the tests we were doing earlier on. What happens when I put it with a hydroxide? Now, I didn't put it with a sodium hydroxide, which was naturally basic. I put it with water. So this substance right here, it would be neutral. All right, so if I put a metal in water, this is what I would expect to happen. But the trouble is, metals aren't soluble. All right, so that would be one that we can't expect to change. So metallic bond, not going to do anything. All right, if I put an ionic in there, a metal with a non-metal, I would get a metal hydroxide, and I would get hydrogen with a non-metal. All right, so then if I do this, I would form an acid and a base. So we'd have to see some pH changes there. All right, so the quick way to know what this is, all right, is as follows. If I put a metal plus water, I will get a metal hydroxide. And because it's a hydroxide, it'll be basic. I will get a pH of greater than 7. If I take a non-metal oxide or a non-metal plus water, right, these substances are going to form acids. All right, so metal oxide or a metal plus water gets me a metal hydroxide. A non-metal oxide plus water gets me an acid. So you'd have pH less than 7. All right, so what types of categories would fit this? All right, your metal oxides, these are ionics. All right, so if I get a metal oxide, it will dissolve in the water and I'll get a reaction. Your non-metal oxides, these are your polar covalents. Right, so I ran through some of the reactions so you understood like why you were seeing what you were seeing. But if I get a basic pH when the substance dissolves in water, I know it's ionic because it dissolves and the pH will be basic because I'm forming a metal hydroxide. If I get a non-metal oxide plus water, it's polar covalent, which means it should dissolve in water, like dissolves like, right? But I'm going to make an acidic compound when that reaction occurs. Its pH will be less than 7. All right, so I just wanted to run you to the back and kind of walk you through each of these tests. Not in any great detail, but just to show you what you'd be looking for. All right, so the first one here, and there's each of these signs that you see is attached to your data table document that I shared with you. All right, so you guys can see what these are, right, but it's just telling you how to conduct the tests. All right, so when you guys come back to the lab, usually the first thing you would do is you would come back and you would run tests on a series of the known substances. All right, so here's your copper 2 sulfate, here's your dextrose, here's your zinc, here's your paraffin. All right, so you would just run around the back with your known substance and you would start testing things. So if we showed you the first test, here's what your setup looks like if we're checking its melting point. So you have a beaker of water that's got a little dish in here. And what you would do is you would sprinkle a little bit of that solid onto the dish. And that water would be boiling usually. And we know boiling water is at 100 degrees Celsius. So if the substance melts, you know it has a melting point below 100. You would see it liquefy. If it doesn't melt, you know its melting point is above 100, right? And it stays the solid. And that starts to tell you about bonds. The nonpolar covalent would liquefy. So if I saw this thing liquefy, I'd say, hey, there's a good chance that's nonpolar covalent. If it didn't, all I know is it's one of the other three. So you start running around and doing a bunch of other tests. Here's my pH of a solution in water test. All right, so we'd take a sample, we'd add 2 milliliters of water to it. We'd see if it dissolves, and if it dissolves, we'd use our pH meter, and we would just stick the substance, put it down into the test tube with it, and we would record a pH. We'd be looking for reactivity there. Like, does it make a basic? Does it make acidic? If it's a basic, it makes me believe it to be ionic. If it makes an acidic, it makes me think polar covalent. Here would be my reaction station. Reaction with NaOH. Reaction with HCl. And those are simple enough. There's just a beaker with a pipette in it, right? And you just take your solid, put 2 milliliters of distilled water in it to get it to be dissolved, and then you add the NaOH. What you'd be looking for there would be, do I see a precipitate? Right? If I don't see a precipitate, it means it's probably not ionic. If I do see a precipitate, there's a chance it's going to be ionic. I do the same thing with the acid. The acid's my confirmation for metallic. If I see bubbles, it's a metal. All right, so we would be looking for bubbles in that one. Same setup though, and there's nothing crazy exciting about the test. It's just running a series of tests, like doing blood work on the solids. Come over here, and then this would be what we call our solubility station. I would have 3 different beakers that had water, ethyl alcohol, and hexane in it. You would take 2 milliliters of each of those out, and you would see, can I get my solid substance to dissolve in that? So we're running a bunch of tests, all right, over and over again to see if we can figure out what the bond type is. So the first thing you'll do is you'll go ahead and you'll look at this data table, which I've shared with you. And this will be what you should have seen for your known substances. So the copper 2 sulfate is ionic, the zinc is metallic, the paraffin is nonpolar covalent, the dextrose is polar covalent. So you scan across, and now you have a template of what should each of those substances do. And then you'll go on to the unknown table, and there's a ton on here. You're only going to identify 6. Right? If you are a girl, right, I'm going to have you do the A substances. If you are a boy, actually I lied. One of the people in the group, you have partners. One partner is going to do the A substance. The other partner is going to do the B substance. All right, now remind you of that in class, but this is attached as well, and you have all of your results done. All right, so I'll give you a quick refresher on that whenever we sit down in class together. But hopefully this gets you at least a feel for what you would have done in the lab, and then you can dive into all of the questions and interpreting the tests and what type of bond are those substances inside. All right, and I will see you guys soon.